Hello everyone. Have you ever wondered how your brain helps you recognise your friend's face in a crowd, decide what snacks you want, or remember the rules of your favourite game? Well, today we're diving into something that works in a similar way, but inside a computer. We're talking about neural networks. Think of your brain as a team of tiny helpers, each with a specific job. These helpers work together to help you understand and respond to everything around you. When you see your friend, some helpers recognise the shape of their face, others their eyes, and so on, and together they let you know, hey, that's Jamie. Neural networks in computers are like these helpers in your brain. They're made up of layers of even tinier units called neurons. Each neuron has a job to take in small bits of information, process it, and pass it on. Imagine you're looking at a picture of a cat. Your brain helpers spot the pointy ears, the whiskers, the furry face to tell you that that's a cat. A computer's neural network does something similar. It looks at the pixels in the photo and learns to recognise patterns, like what makes a cat a cat. Now let's look at the basic structure of a neural network. Picture in your mind three main parts. You've got the input layer. This is like your senses, your eyes, your ears, your nose, taking in the world around you. In a neural network, each neuron in this layer represents a piece of information it gets, like a single pixel in a photo. Then we've got the hidden layers. These are the brain's processing centers. They take the information from the input layer, mix it up and try to make sense of it. The more layers there are, the deeper the thinking. It's like having a brainstorming session where ideas are shared and refined. And then you've got the output layer. This is like making a final decision based on the information processed. For example, deciding if a photo shows a cat or a dog. It's the final aha moment when everything clicks into place. Let's now look at how neural networks learn. Now, neural networks don't just work out of the box. They need to learn, like you do. Now, we touched on this in the last video, which was about machine learning, but let's look at this again in a little more detail and in the context of neural networks. It starts with something called forward propagation. Imagine you're guessing a friend's mood based on their facial expressions. You look at their face and you make a guess. Now we have something called loss calculation. You check how good your guess was. If you guessed wrong, you figure out if they were happier or sadder than you thought. And then we have something called backward propagation. You learn from your mistakes. You remember that certain smiles mean happy and certain frowns mean sad. And this is repeated. We have iteration. You keep practicing with different faces, and the more you practice, the better you get at reading expressions. Now, when we discuss neural networks, we often hear the term deep learning. Now, deep learning is like neural networks on steroids. It uses very complex neural networks with many hidden layers, kind of like a super sophisticated version of your brain. This allows a computer to learn really intricate stuff from lots of data. For example, a deep learning model could learn to identify every breed of dog by looking at thousands of pictures. Imagine being able to tell the difference between a beagle and a bulldog just by looking at them. So let's wrap all of this up with an example. Think about playing a game where you need to guess the animal in a picture. A neural network that has learned from many animal pictures can guess correctly by noticing patterns. Stripes might mean tigers, a long neck might mean a giraffe. Each picture it has seen helps it learn better for the next round. Initially, it might make mistakes with the first few images. However, as it processes more and more images, the neural network begins to notice increasingly specific details and patterns that uniquely identify each animal. Through this continuous learning and positive reinforcement, neural networks become more and more effective at making accurate guesses. So neural networks are like tiny helpers in your brain working together to recognise patterns and make decisions. They're incredibly powerful tools, and they help computers learn from data and make sense of the world just like we do. Thank you for joining me on this journey into the fascinating world of neural networks. Keep exploring, keep learning, and who knows, in the future, you might just create the next big thing in AI. Thank you, and see you next time.